Students, now we will discuss integration by substitution. Our next problem is integrate 1 upon x into under root of x square minus a square with respect to x. Now solution is, let capital I is equal to integration of 1 upon x into under root of x square minus a square with respect to x. I repeat again, let I is equal to integration of 1 upon x into square root of x square minus a square with respect to x. Let it be equation number 1. Put x is equal to a secant theta. So this implies theta is equal to secant inverse x upon a. Let it be equation number 2. Now differentiate both sides. So we get dx is equal to derivative of a secant theta. Now as a is constant, so we can take it out in the right hand side. So this implies dx is equal to a into derivative of secant theta, and this implies dx is equal to a into secant theta into tan theta into d theta. A derivative of secant theta is secant theta into tan theta, and d theta is according to chain rule. Therefore, from equation 1, by putting these values, so we get capital I is equal to integration of 1 upon a secant theta, the value of x, into square root of a square secant square theta minus a square. That is putting the value of x, and in the numerator dx is equal to a into secant theta tan theta into d theta. D theta represents that the integration is now with respect to theta. Now within integration, secant theta cancel each other, and also a in the numerator cancel with a in the denominator. So therefore we get capital I is equal to integration of tan theta upon square root of a square. In the denominator we can take a square common, so under root a square into within the bracket secant square theta minus 1. As a square is common, so we can take it common. So we get I is equal to integration of tan theta upon square root of a square into within the bracket secant square theta minus 1 into d theta, means integration is with respect to theta, or I is equal to integration of tan theta upon square root of a square tan square theta, because secant square theta minus tan square theta is equal to 1. So by using this formula, we can prove secant square theta minus 1 is equal to tan square theta. So putting the value of secant square theta minus 1 is equal to tan square theta. So we get capital I is equal to integration of tan theta upon square root of a square tan square theta into d theta. Means integration is with respect to theta. Now in the denominator, square root cancel with square. So we get capital I is equal to integration of tan theta upon a tan theta into d theta. Mean integration with respect to theta. Now within integration again, tan theta cancel with tan theta. So we get it is equal to integration of 1 upon a into d theta. Now as a is constant, so we can take 1 upon a common. Therefore we get I is equal to 1 upon a integration of d theta, and it is equal to 1 upon a into theta, because integration of d theta is theta. So this is equal to 1 upon a into theta plus c, constant of integration. Put this equation number 3. Now putting the value of theta from equation 2 in equation 3, so we get I is equal to 1 upon a into secant inverse x upon a. This is the value of theta plus c, the constant of integration. Hence, integration of 1 upon x into under root of x square minus a square with respect to x is equal to 1 upon a into secant inverse x upon a plus c, the constant of integration. So this is the value of required integration. So thank you very much.